Day 14. Let's build a tic-tac-toe AI using the Minimax algorithm. The Minimax algorithm is a recursive approach used for making decisions in turn-based games like tic-tac-toe. The AI will simulate all possible moves, evaluate them, and choose the best one to either maximize its own chance of winning or minimize the player's chance of winning. Let's get started and let's run through this project. So for this, I am going to go to my day 14 folder and create a day14.py file. So step 1 is defining the board. So I'm going to define the board. The tic-tac-toe board is represented as 1D list of 9 elements, indexes 0 to 8, and each element starts as an empty space with double quotes or quotes spaced to indicate that the slot is available for a move. Next step is function to print the tic-tac-toe board. So I'm going to create a function print board, and here I am going to run from each board element. What this function prints the board in a user-friendly format. It divides the 1D list into 3 rows, each containing 3 elements, and prints them as rows separated by vertical bars to mimic a tic-tac-toe board. So that's why here from I'm going from each element and printing those pipes to separate them as elements. Next, we write function to check if there is a winner. To do that, we'll create a function called as check winner and pass it the board and the player. Now, what are the different win conditions? So let's look at those win conditions. As per rows, so if you have 0, 1, 2, or 3, 4, 5, 6, 7, 8, any of these horizontal rows, you win. Second is columns 0, 3, 6, 1, 4, 7, 2, 5, 8, then you win. And then we also have two diagonals. One is 0, 4, and 8, and 2, 4, and 6 sideways. So that those are our win conditions. Now what we're going to check here is we check if condition in win conditions, if board condition 0 is equal to board condition 1 equal to board condition 2 or equal to player, then we are saying return true, which means they won. Or else we'll say not yet, there is no winner. Next, we'll look at function to check if the board is full, because if there's a full, then we probably might have a winner or it's a tie. So check is board full. In this case, we're going to return empty, not in board. So if what happens here is if there is a slot which is not filled, then it's not full. If it's all full, then it means it's full. Next, we're going to do a function to evaluate the board for Minimax algorithm. Here, we will create a function called as evaluate and pass the board to it. And we're going to check if the winner board is 0, then AI is, in this case, AI is 0, return 1. Else, if check winner board X, where X human is X, then return -1. Else, we'll say return 0. So this evaluate function assigns a score based on the current board state. One is the one if the AI, which is 0, wins, -1 if the human player, which is X, wins, and 0 if the game is still ongoing and ends in a draw. Now, next step is minimax function to calculate the best move for the AI. So for this, we are going to create a minimax where we will function minimax, which where we'll pass the board, depth, and is maximizing. Now, is maximizing is if true, it's the AI's turn, and the algorithm tries to maximize the score. If false, it's the human player's turn, and the algorithm tries to minimize the score. So let's go and look at the score first. First score is evaluate board. So we're going to evaluate the board over there. Then if score is 1 or score is equal to -1 or a score is board is full, like the board is full, then we'll return the score. If is maximizing, which is AI turns, then best score equal to minus float inf. For I in range of 9, we'll say if board I equal to empty, then board I equal to 0. AI makes the move. Best score, where we'll check max of best score, minimax, board depth, board comma depth plus 1 false, and then board of I equal to empty. We'll undo the move. return the best score in this case. Else, it's human's turn, where we'll say best of score and equal to float of inf. For I in range of 9, we'll say if board of I equal to empty slot, then board of I equal to x, where human makes the move. Best score, minimum of best score, comma minimax, board depth plus 1, comma true. Then we'll say board of I equal to empty, where we'll undo the move and we'll say return the best score. Next, we'll do the function to find the best move for the AI. Now in this case, we'll call the function find best move and pass the board to it. And we'll say best value equal to minus float inf and best move equal to -1. Now we'll go through for I in range of 9. So we'll check each and every move. If board is I is empty slot, then we'll say board of I equal to 0, where AI makes the move. We'll check move value minimax board 0 and false and see if it's a best move. Then we'll do board of I is empty slot, where undo move, and we'll check if the move value is greater than best value, then best value equal to move value and best move equal to I, and that's what we will return, because that will be the best move that AI can make. Again, this find best move, this function loops over all the available positions on the board, simulates the AI making a move at each position, and uses the minimax algorithm to evaluate the move. It chooses the move with the highest value, best move for the AI in this case. Now let's go and do the player's move. So this is the main game loop. So we'll say define the play game. While true, while the game is still going on, we'll say print board and print the board based on what the board is doing right now. We'll say let's say player move. Now player move equal to input, enter your move 1 to 9. So we're going to ask the user to enter one of the pick one of the slots. Now if the board of player is not equal to an empty slot, we'll say invalid move and try again, and then we'll give that call that function again, or else we'll put a x on that particular slot. Next, we'll also check if the player has won. So if check winner board of x, we'll say print board and say you win and break out of it. It's very difficult, but we'll see if the player can win. So again, this play game, this is the main game loop where the human player enters their move by providing a number between 1 and 9 to correspond with the board positions. If the position is valid, that is empty, the player makes their move x and the game checks if the player has won. Now next is AI's moves and checking the game status. So we've missed out one point, which is check for the draw. So if is board full, board and print it's a draw and break out of it. Now it's AI's move to check if like kind of print right now. AI is making its move, and AI move find the best move, which is the function that we wrote above. So it's going to call that and make the AI's move over there. After the AI makes the move, we will check if AI won by checking if check winner board of 0, then print board and we'll say print AI wins. If not, then we'll check for a draw. If the board is full, print the board and say it's a draw and break out of it. And that's the entire game loop. So let's go and start the game. So to start the game, I'll say play the game, call that function, and that's about it. So after the player moves, in this particular case, the AI calculates the best possible move by calling the find best move function here and places its move on 0. And let's start and see how well the AI can play this game. So I'm going to go back here and say let's clear it out. Python day 14.py. So we have that empty slot that I mentioned, 3 by 3 slot. So I'm going to pick the middle one, which is 1 2 3 4 5. So I'm going to pick the 5th slot, and the AI picked the top slot. Now I want to be a little bit tricky in this case, so I'm going to pick this bottom 1 2 3 4 5 6 7 slot. There you go, and then AI put the button here. So now I have to put the second one, because or else AI will take over that spot. Looks like it's going to end up in a tie. As I mentioned, it's very difficult, so I'll let AI try to win and give 4, and it's going to put their value there, and I'm going to put 9. It's a draw. So, as I mentioned, it's a very difficult game to win if you want to make a tie. And that's our tic tac toe AI using Minimax algorithm. I hope you were able to implement it. If you had any problems or questions, let me know and I'll get back to you.